Move, y'all. Thank you for coming to my talk. This is Move for Solidity devs. My name is Rahat. I'm going to be telling you a little bit about what we're doing at Movement, how you can get started building on top of Movement, and yeah, let's get right into it. So I'm Rahat, senior DevRel engineer. Been DevRel in a few different places in the Web3 ecosystem for a while. Formerly a hip hop artist. I don't do that anymore. I no longer take requests for freestyles. I kind of suck at it now, so it's been a while since I've done that. Been a front-end engineer, freelance Solidity dev. So I came into the Move ecosystem from the VM side of things. So some of this is kind of going through a little bit of what I wish I kind of had when I was going into the Move ecosystem myself. So quick agenda. We'll do a quick history lesson on the Move ecosystem in general. A little boring, I'll try to keep it short. We'll talk a little bit, very high level, about the Move virtual machine. We'll have an overview of Movement, how we're kind of like bringing this over to Ethereum. And then we'll look through a couple of code examples and snippets so you can kind of like solidify some of the concepts that we talked about. Cool. So brief history of Move. Where did it come from? Where did it start? A few years ago, Facebook was actually looking at building out a blockchain underneath their social media platform. And that was two teams, or one team, I suppose, DM and Libra teams who were coming in, building out the Move VM, the Move language. And initially, this was supposed to be a chain that powered some of like Facebook's like payment type of systems that they wanted to go into. Unfortunately, at the time, the SEC decided, no, Facebook, you cannot do this. And so the DM and Libra teams kind of like branched out. Some of them went on to become the Aptos chain. Some of them went on to become the Sui chain. So right now, the two most popular chains using the Move language are Aptos and Sui. And over us at Movement and a few other chains are now also coming up with new Move chains. And us especially, we're building out something on top of Ethereum. So before we go into a little bit more on Movement, what exactly is the Move VM? So again, very high level, the Move VM is a runtime that executes Move bytecode. This is similar to the VM, executing Ethereum bytecode that's compiled from Solidity and Viper, but we're looking at using the Move programming language instead. So the Move programming language emphasizes safety, flexibility, and a resource-centric design. And we're going to go into each of these when we go into the code examples. But essentially, it gives you an environment that has a lot of like VM-level safety features. And I'm not going to say it's safer or better than Solidity. That is up to you to decide whether that is true or not. But it does give you an environment where it makes it a little bit easier to avoid some of the common kind of like pitfalls that you might see in Solidity contracts. So for an EVM developer, you can kind of think of the Move VM as a specialized environment in which every piece of data is treated much more rigidly. Particularly anything declared as a resource, and that's going to be the big thing that we focus on today. And the language's design ensures that the assets behave the way that real-world assets do. No implicit copy, no accidental deposital, things like that. And we'll kind of like contextualize that in a bit. So what's Movement, and what do we have to do anything here? So Movement Network, public mainnet soon, TM. That's all I've been asked this week. But very, very soon, keep an eye out for announcements coming out there. But what the Movement Network mainnet will be, it's going to be a proof-of-stake sidechain on Ethereum. The Movement Network is the first Move chain that is built using the Move stack. The Move stack is going to be sort of like an SDK and a set of suite of tools that other folks will be able to use in the future to build out their own Move chains. Our goal really is to bring the Move VM to Ethereum. And ultimately for me, the way that I've been approaching this, at least on the DevRel side, as I've been talking to devs, as I've been trying to onboard them to the Move language, is really just this question. It's like, what if we could just provide devs with another environment with some of those safety level features ingrained within the VM level? So let's just jump into some code. So on screen, you'll see just like your basic Solidity greeter contract. If you've onboarded and learned through Hard Hat, you probably remember seeing this contract whenever you spun up a Hard Hat back in the day. probably one of the first couple of contracts you've ever maybe looked at as a Solidity dev. So we're going to take a look at like how this converts over to Move and talk about some of those like concepts of safety as well. This is what the contract looks like written in Move, so slightly bigger. We're going to be going through some of these in a bit. This does have a couple of additions, a little bit of error handling, and a few other things in there that we'll be talking about in a second. Has a couple tests written out in there too. So, well, how do smart contracts actually work, right? So in the Move VM, actually, before I continue there, one thing to kind of note, I mentioned before that the major players in the Move ecosystem have been Aptos and Sui. Both of these companies have slightly different variations of Move. At Movement, we use the Aptos Move VM. So if you are coming from the Aptos ecosystem, we're pretty much one-to-one with their tooling. So if you know Aptos Move, you already know how to build on Movement. So modules and smart contracts. So modules are smart contracts. A module is published at a specific address. So for example, 0xmy address will have a specific module. It can have several modules in there. It's kind of like one of the first things I had to kind of like conceptualize myself. When you're looking at the EVM Solidity side, when you deploy a contract, each contract has its own address. It's slightly different on the Move side. Rather than each contract or module having their own address, you're deploying specific modules to an address. So you have your deployer address, and you can essentially deploy multiple modules to that address. So users store what are called resources defined by that module into their own accounts, and we'll take a look at that in the code in a sec. And the way that you would interact with the contract is via entry functions. So entry functions are just the functions that you would create scripts to interact with from your front ends, from your scripts, wherever. And you have your view functions as well, which do not update any state and are just used for read-only access. So this is the first part of that long kind of module that I had written out before. This is kind of like how you define a smart contract on the Move side. You have your module, you have what's called a named address in this case. So the hello blockchain is actually corresponding to an address. So that is going to be the address that I'm deploying to. I would set this in like my configuration of whatever address that should be. And then message is the actual name of my module. And you can see that a little bit in action with how I import other libraries throughout the rest of the contract. So you'll see that the way that imports kind of work is that you're using the use keyword, and you're importing from a specific address. So the STD or standard library, that is referring to the 0x1 address. So at 0x1, we have several different modules that I can import. One of those can be error, signer, string. In the case of string, I'm going one level deeper into the module and importing the string type. I can also import different functions for strings from that as well. But essentially, how you would import is you specify the address, you specify the module, and then you can go one level deeper, specify any types or functions that you want to import as well. Aptos Framework is another address that has several more kind of like library tools for you to use. In this case, there is, we're going to be using an account, an event module that will help us deal with our any accounts that we're using and emitting events. So I've talked about resources a couple different times. I've mentioned them. So what exactly are they? So Move applies what's called resource-oriented programming, meaning assets, which are resources, are treated as first-class citizens with very, very strict rules. And the goal here is to prevent things like duplication or destruction of on-chain assets like tokens or NFTs. So resources have different things called qualifiers. A couple of them are key, store, and drop. If it has a key qualifier, that means this resource can be published to an account's global storage. If it has store, it can be used in local variables or passed between functions. If it has drop, this allows resources to be explicitly dropped or destroyed without calling a custom function. So if a resource lacks the drop keyword, the Move VM enforces that it can only be destroyed via a module that defines it, e.g. like a burn function. So this gives you, like, again, these different qualifiers will give you different protections on the VM level. So adding a bit more onto the contract, now we're defining two resources. Resources are defined with structs. My first struct is just this message holder resource. I gave it that key qualifier, so if you remember, this allows the resource to be published in an account's global storage, and we'll see how that kind of works out in a second. But the message holder struct has two things. The message, which is just a string, and I'm using the string typing that I imported from the standard string library, and a message on-chain event that we're going to admit, and that event is then defined in the following struct below there. So here now is kind of like the first entry function for actually setting your message, right? So if you recall back on the Solidity contract, you might do this in like your constructor, where when you deploy your smart contract, you set your message. In this case, the way that this is done is we check to see if a resource, in this case the message holder resource, actually exists on the account that is interacting with the contract at the time. So in this case, message holder, this is the actual resource that I defined. Does it actually exist on this account? If it doesn't, what we're going to do is take that resource and move it to the account that is interacting with it. An account cannot have a resource until you've actually moved the account over to it, hence the programming language move. So in this case, we're moving the message holder, which will have the message and the event associated to it. And we set that down here and emit the event up here as well. So how resources are moved in Move. In that snippet, we use the move-to function. And this places a new message holder resource into the caller's account. If that resource doesn't exist, we created it, and this ensures that there's no accidental duplication. Only one message holder resource can exist per account unless the code explicitly allows more. So if the message holder already exists, we fetch it using this borrow global mutation function. And this gives us just like a mutable reference so that we can update it if need be later on. And the move VM essentially enforces that no other references can be made simultaneously, which helps you with making sure there's no partial data updates, which can lead to things like reentrancy. So why this matters if you're building something a little bit more robust out, let's say you're doing some type of token contract, NFT type of contract, you have much more safe minting and burning capabilities. You can use the move to burn move from these helpers with like moving resources in and out of accounts. You have VM level safety like I was mentioning from double minting or inadvertently dropping these resources. There's much more clarity around the ownership and lifecycle. A user's balance or NFT or message resource lives in their account. So rather than, let's say, creating like a mapping between the address to whatever their balance is and having to manage that yourself, because you're moving the resource to that account, you can simply access the actual resource directly from the account itself. So this resource-based system kind of like naturally models ownership and transfer logic of assets in real life. So continuing on with the smart contract, we have just our basic view functions. Not too different, I guess, from the Solidity side of things. You have a function to get the message. What this is going to do, so like I mentioned, resources have to be actually attached to an account. So the first thing this will do is just take a look whether this address has a message resource. So that's this assertion over here. We have just like this error message defined up here. We'll throw that error message if the message doesn't exist. Otherwise, we'll borrow from the global state of that address and display whatever the message is. Testing is also very nicely done within the VM. In Solidity, you'd use, let's say if you're using Rahat, you'd probably do your testing via JavaScript. Using Foundry, you're able to do your testing via Solidity. On the Move VM, it comes like built-in testing suites, so you're able to define your test right inside your module if you want to, or create like a separate module for your tests, either way. You define tests using this hash test over here, and you can define accounts as well that will act as signers within those tests and run your tests. This is just a basic test looking at whether this account is able to create a message here or not. So yeah, like I was mentioning, Move includes built-in testing framework. You can define test entry functions inside the same module or a dedicated test module. The 0x1, like I mentioned, spawns a test scenario with a signer at address 0x1. That can be whatever you want it to be. Testing can create accounts and call your entry functions in a controlled environment. So where do we go from here? There's a couple different places you can check out if you want to kind of like dive a little bit deeper, start learning some more of the syntax. If you're coming from Solidity, Move is a Rust-based language. So if you've ever done Rust before, you might be a little bit more familiar with Move syntax. With that said, though, we do have a bunch of resources for getting folks up and ready. These are our docs. This is docs.movementnetwork.xyz. It goes over some of the code that I went over during this presentation, as well as interacting on chain, different network RPC endpoints, and all that. We also have our developer portal, which can give you more in-depth guides into just learning Move in general. If you want to just like get like a deeper understanding of some of the concepts I went through, we do have a couple of guides and tutorials here. This one I recommend. My coworker Cheyenne built like an on-chain Twitter clone, and this goes into some of those like resources, resource accounts, and how some of those movement of resources work in like another context here as well. So with that said, these are some of the resources that we're providing. We're right now kind of like gearing up for our public mainnet release, which will be pretty soon. And yeah, excited to be able to be here and give you guys an introduction to this. Happy to answer any questions later on. I'll be around. And yeah, thank you for tuning into the talk.